Kia ora koutou. Welcome to this video where we will look at 2D covalent networks. The only 2D covalent network we need to know is graphite. So we will look at the structure and bonding of graphite. So here's a diagram of graphite here. You can see these black circles represent a carbon atom. So each carbon atom is bonded to three other carbon atoms, 1, 2, 3. And so if we think of carbon, we know that carbon has got 4 electrons in its outer shell, so it's able to make 4 covalent bonds. So it's curious to think that it's a stable structure that only has uh, three covalent bonds there. So what is actually happening is you've got those carbon, each carbon has got 3 covalent bonds, and that one free electron is hanging out in between the layers. So actually what we would see is that in between these layers of graphite, we've got electrons that are delocalized and free to move throughout the structure. So that might give a hint as to what the properties of one of the properties of graphite might be, which we will get into in a minute. So I've just drawn two sheets here, well, two squares. This is to represent one sheet of graphite and another sheet of graphite there. The sheets themselves, so this would be carbon atoms bonded together with covalent bonds in a hexagonal shape. So you can see what I mean by the hexagonal shape is there's all the hexagons within the structure there. So this square is just representing one of those sheets. In that diagram before, I showed that there were the electrons between the layers. The other thing about the thing holding the layers together is that we have weak intermolecular forces holding these layers together. So that's going to give us another particular property as well. So weak intermolecular forces hold the different sheets together, and within the sheet itself, the sheet is held together by strong covalent bonds. So covalent bonds are really strong, intermolecular forces are very weak. So we'll show how this relates to boiling point and the hardness of the covalent network in a second. So there's a strong. To write a description of the structure and bonding of graphite, I've just taken this from a previous year's exam. We would say that each carbon is covalently bonded to 3 other carbon atoms in hexagonal layers. So that's describing the shape that they arrange themselves in, and this leaves one delocalized electron per carbon atom. So that's a word answer for how to describe what we've just gone over there. So we'll look at the properties of graphite. So first of all, the hardness. So this is an interesting one because normally when substances are hard, they will have a high melting point as well, or if they're soft, they'll have a low melting point. With graphite, because we've got these two different types of bonds here, we've got these weak intermolecular forces and the strong covalent bonds. These sheets are easily able to slide past each other. So graphite is often the lead within pencils. So it's really important for that lead to be able to slide past each other and slide off onto the page. And that's thanks to these weak intermolecular forces. So what we would say about graphite is that actually it is soft because it has weak intermolecular forces holding the layers together. And so this doesn't require very much force to shift layers. So graphite is actually very soft. Whereas the melting point, and this is where it gets slightly confusing, to melt graphite, what you need to do is to be able to break these covalent bonds. And because these covalent bonds are really strong, graphite has a high melting point. So this is the only substance that you will see that is soft and has a high melting point. Normally it will either be hard with a high melting point or soft with a low melting point. So graphite is slightly different. Melting point is high. And that's because with our explanations we need to remember that we're saying it's high because of the covalent bonds and it's soft because of the intermolecular forces. Electrical conductivity, you can probably guess this, we can say that yes, it does conduct electricity because each carbon atom has that delocalized electron. So one delocalized electron per carbon atom. So if we were writing an explanation about that, we would need to use this kind of answer there. This is the most common property of graphite that you'll be tested on, so make sure you're all good with that. And then solubility, because the forces between water and these carbon atoms is not strong enough to break the covalent bonds within the substance itself, graphite is not soluble. So not soluble. Nope. An exclamation mark. Why not? So that's all for graphite. Thanks very much for watching. Like and subscribe for more 2.4 videos. See you next time.